Hello, welcome to today's lesson on argument of a complex number part 2. In our last video, we had treated a part 1 of this topic where we define an argument of a complex number as the angle which a complex number makes with the positive real axis. So, you check the description below for the link to the video of part 1. Without wasting so much time, example. Find the argument of the complex number z equal 2 plus 2 root 3i. So we want to know what the argument of this complex number is. Like we explained in the first video, the first thing we ought to do is to locate in which quadrant this complex number falls. And from this complex number, you see that the real part is positive and the imaginary part is also what? Positive. Hence, this complex number must fall in the first quadrant. So let us sketch. So we have the following sketch for it. So 2 plus 2 root 3 falls in the first quadrant of our complex plane. So the argument of this complex number is the angle theta which a complex number makes with the positive real axis. So if we complete this triangle here, a right angle triangle, we have the following. And the real part is 2, so the real part is 2. The imaginary part is 2 root 3, which is 2 root 3. So we proceed to find theta. So the tangent of angle theta is what? The absolute value of 2 root 3 over 2. And that is nothing but what? Root what? 3. So we have that the tangent of theta is root 3. So what is theta? So theta is the tan inverse of what? Of root 3. And that will give us what? If you punch your calculators, you have that the tan inverse of root 3 is 60 degrees. And most times our results are expected in radians. So to change 60 degrees to radians, we multiply by pi over 180 degrees. And that is simply what? Pi by 3 radians. So the argument of the complex number 2 plus 2 root 3 is nothing but what? So the argument, we write ARG of the complex number 2 plus 2 root 3i is equal to what? Pi by 3 what? Radians. And that is because the complex number given to us falls in the first quadrant. So let us see what happens if this complex number should fall in the second quadrant. So if we have z equal minus 2 plus 2 root 3i, this way the complex number now falls in the second quadrant, since the real part here is negative and the imaginary part here is what? Is positive. So the real complex number falls in the second quadrant. So the argument therefore is this angle here, angle theta, which it makes with a positive what? Real axis. So like we did before, to get angle theta, we first of all calculate the value of the acute angle here, which we called A. So the real part is negative 2, and the imaginary part is 2 root 3. So the tangent, tan A, in this case will now be the absolute value of what? Opposite over adjacent, which is 2 root 3 over what? 2. So once again, we have that tan A is equal to what? Tan A is equal to root 3. So that A is equal to the tan inverse of root 3, which is equal to what? 60 degrees again. In radians, that is pi over 3 radians. But recall that A and theta are complementary angles, right? Are supplementary angles rather. That means they sum up to 180 degrees. So we recall again that angle A plus angle theta is 180 degrees. In radians, that is nothing but what? Pi. So that angle theta, the argument theta is equal to what? Pi minus A. So to find the argument of the complex number given to us here, we simply say, okay, the argument of the complex number theta is equal to what? Pi minus A. And what is our A? Our A is pi over 3. Pi over 3. And if you tidy this up carefully, what do you get? You get LCM there is 3. You get 2 pi by 3. So the argument of that complex number, the argument of z, where z is what? Minus 2 plus 2 root 3i is nothing but what? Nothing but 2 over 3 pi. So let us see what happens if the complex number is found in the third quadrant. So z equal minus 2 root 3i. This complex number is located in the third quadrant because In the third quadrant, the real part is negative and the imaginary part is also what? Negative. So the complex number can be found somewhere here in the third quadrant. So that if we join up here, we have is our origin and the complex number is just there, z. Now, the argument of the complex number again is the angle it makes with the positive real axis. This time around with transverse in the clockwise direction. So angle theta. We want to find the value of angle theta. Recall again that to find angle theta, we want to first find the value of this acute angle here, angle A. So if we complete this triangle again, what do we get? We get the following. Now, the real part is minus 2, the real part is negative 2, and the imaginary part is minus 2 root 3, minus 2 root 3. So, what will be tan A? So, our tan A again is what? Is the absolute value of what? Opposite over adjacent, which is 2 root 3 over 2. And if we go over it again, you see that A is nothing but what? Pi over 3. But we recall again that the sum of A and theta is nothing but what? 180 degrees. So recall again that A plus theta is what? Is pi. So that theta is equal to what? Pi minus what? A. But since the angle now, the argument theta is in the clockwise direction, the clockwise sense, then that angle is always what? Negative. So theta is nothing but negative of minus pi minus A. So if you open up the bracket, you get minus pi plus A, which is nothing but what? A minus pi. So the argument theta of this complex number given to us here is nothing but what? A. What is our A? Our A is pi over 3 minus what? Minus pi. And the LCM here is 3. If you tally it up carefully, what do you get? This is pi minus 3 pi. That is minus 2 over 3 what? Pi. So the argument of the complex number in the third quadrant, minus 2 root 3i, is nothing but what? Negative 2 over 3 what? Pi. So now investigate what happens if the complex number is in the fourth. So in the fourth quadrant, the real part is what? The real part is positive and the imaginary part is negative. So we have 2 minus 2 root 3i. So the complex number can be found here in the fourth quadrant. So z, we have 2 and then minus 2 root 3. So if we draw this line here, we have that to be our complex number. And this is the origin as usual. So the argument of the complex number again is the angle theta, which the complex number makes with the what? The positive real axis. So to find theta, we complete again this triangle here. So tan theta will be what? So tan theta is nothing but what? So we have the real part is 2, the real part is 2, and the imaginary part is negative 2 over 3 minus 2 over 3. So tan theta is what? The absolute value of what? 2 root 3 opposite over adjacent over 2. And once again, theta is nothing but what? 60 degrees, which is what? Pi over 3 in radians. But recall that we said that since we transverse our angle, in the clockwise direction or in the clockwise sense, then angle theta must be what? Negative. So the argument of that complex number, theta, is equal to what? Negative what? Pi by 3. So we have just demonstrated in this, in this video, how we calculate or obtain the argument of complex numbers depending on the quadrant which the complex number is found. In our next video, we shall be dealing with what we call polar form or trigonometric form of complex numbers. So subscribe so that you may never miss.